Braun was finally able to lay out a grand blueprint for the conquest of space. History has clearly shown that the Collier series of 8 articles, published over a 2.5-year span from 1952 to 54, had far-reaching impact on the public and the scientific community. To assist in explaining the novel concepts in the series, Collier's art director hired 3 of America's finest illustrators to work with their writers. It was a fortunate decision for the 3. Chesley Bonestell, Fred Freeman, and Rolf Klepp soon created a series of stunning visuals under the supervision of von Braun. They stand unsurpassed as the most influential works of their kind ever completed on space. The momentum created by the Collier series continued after the final issue. The series had come to Walt Disney's attention just as he was planning a new television series, and he quickly became an ardent space enthusiast. Soon, von Braun and several of his colleagues were named technical advisors in a 3-part Disney series based on von Braun's visions of space travel. The programs were an instant hit and contributed to growing public interest in space. The conversion of von Braun's theory and designs from sketch to blueprint to finished art was a complex one. Von Braun created his spacecraft by first preparing engineering drawings of his concepts, as these original examples reveal. His 1953 baby space station was to be orbited by a 3-stage rocket whose upper stage would contain the payload.
On the right side of this picture, you see a large wheel-shaped space station, which should be construed more or less as a proposal as to what you could possibly do with a space station. And it is not necessarily a proposal that a space station must look exactly like the thing in particular, must be that large. In fact, it can be a lot smaller if you want to reduce the equipment aboard or prefer to have several smaller ones. The wheel shape has been chosen for the purpose of doing away with the permanent weightless condition prevailing in the orbit. By putting a spin on such a wheel, you could provide an artificial or synthetic gravity in the rim. Inside, such a space station may contain all sorts of equipment. There will be laboratories in the rim where phenomena can be studied which are not accessible to experimentation on the ground. Such experiments may include questions involving biological and zoological life under the conditions of outer space, cosmic radiation, meteorological research, whereby the Earth can be observed from the outside, astronomical laboratories, etc. Close to the space station, there will be a powerful telescope. If you aim this telescope at the heavens, you can see the planets unblurred by atmospheric effects, and we can expect to be able to take photographs of planets like Mars or Jupiter with unprecedented clarity.
These plans were made by Wernher von Braun in 1952. Now, 4 decades later, the United States is assembling the world's first multi-use space platform at the Marshall Spaceflight Center and elsewhere. Although of a different design, America's new space station Freedom will embody many of von Braun's original concepts. Beginning in 1946, and for the next 3 decades, a large part of the nation's progress in rocketry was due to von Braun and his team. One of the early creations was the Redstone missile. Hermann Oberth, von Braun, and Dr. Charles Lundquist contemplate their plans for placing a satellite in orbit using the Redstone. It was later terminated in favor of the Vanguard satellite project. On October 4th, 1957, The Soviet Union won the satellite race by orbiting Sputnik 1, and America's feelings about its space program were changed forever. Then disaster struck. Soon afterwards, President Eisenhower called upon von Braun to urgently proceed with his own orbital launch plans. And on January 31st, 1958, a Redstone rocket orbited Explorer 1, which discovered the Van Allen radiation belts. Soon other von Braun rockets would be lofting more American satellites into orbit. America was in space to stay. 3 men were responsible for the success of Explorer 1. Dr. William H. Pickering, Dr. James Van Allen, and Dr. Wernher von Braun. Project Mercury, the country's first manned space program, was given the go-ahead just 1 week after NASA was formed on October 1st, 1958. 7 test pilots were selected to become astronauts. Donald K. Deke Slayton, Alan B. Shepard, Walter M. Schirra, Virgil I. Gus Grissom, John H. Glenn Jr., Leroy Gordon Cooper, Malcolm Scott Carpenter. They began a grueling training schedule, with von Braun explaining the Redstone rocket that soon would carry 2 of them into space aboard Mercury capsules. However, once again, the Soviets upstaged America. On April 12, 1961, Major Yuri Gagarin of the Soviet Air Force was rocketed into orbit by a Vostok 1 spacecraft to become the first man in space. But at last, Mercury was ready for manned flight. The first astronaut would face great dangers in a program that already had produced a number of spectacular failures. And there would be more. Three weeks after Gagarin's triumph on May 5, 1961, astronaut Alan Shepard made America's first suborbital flight and set the nation on the path to the moon.
Alan Shepard, the members of the House and Senate Space Committee who are with us today, and this decoration, which has gone from the ground up here.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
Neither Shepard nor Grissom, who had followed in another suborbital flight, had achieved orbit. This required the larger, trouble-plagued Atlas intercontinental ballistic missile. On February 20th, 1962, John Glenn became the first American astronaut